guys, I am hoping that this video will be nice and short. So this is going to be a fun math problem for us, and I want to work through finding the integral of e to the x sine of x dx. The first thing that I notice is that I have a product. I have e to the x times sine of x dx, which clues me into using integration by parts. And so our integration by parts model is u times dv, and when we're doing the integral of that, is going to equal u times v minus the integral of v times du. And so we need to identify what do we want u to be and what do we want dv to be. So let's just go ahead and say e to the x is u. And there's this cool little table that you can make. And it helps me remember kind of the format of this problem. And so when I make my table, my u will go right here in the upper left-hand corner. So e to the x is my u. And when I take the derivative of e to the x, I get e to the x dx. And so that's going to be my du. And so I'll just write that up in this box. So this is u and this is du. So this is going to be dv and v. Well, if we've said e to the x is u, then that makes dv sine of x dx. And to get v, we would need to integrate. And the integral of sine x dx is going to be negative cosine of x. Because when you take the derivative of negative cosine, you get sine of x. So now we have the information that we need in order to apply this rule. So what we are going to do is we're going to make a 7. So we're going to make a 7. So we're going to cross here first, and we're going to say e to the x sine of x equals negative e to the x cosine of x, because I multiplied u and v, just like it tells me to here. And then I'm going to complete my 7 by multiplying this way. So negative cosine of x times e to the x dx. And remember, this one is the integral. So minus the integral of negative e to the x cosine of x dx. Now, we're not done with integration by parts until we have dealt with all of the integrals on the right-hand side. So let's go ahead and simplify this. This is going to become negative e to the x cosine of x plus e to the x, the integral of e to the x cosine of x dx. And this is still equaling the integral of e to the x sine of x dx. Well, I have a product. I have a product here. I have e to the x cosine of x, and so I'm going to do integration by parts again. I'm going to do it again to solve for this right here. And so when I do that again, you need to be consistent with your u's. If we said e to the x was our u in the first time, then e to the x is the u again. And so I'm just going to make this little table again, and I'll put my u up in the left-hand corner, which makes my du e to the x dx. My dv would be cosine of x dx, meaning that my v is sine of x, because the derivative of sine of x gives us cosine of x. So now we're ready. We are going to multiply this way and then down like that. So the integral of e to the x sine of x dx equals negative e to the x cosine of x minus, now I have to, I guess plus, because that's a plus sign there. Now I have to actually do this piece of it. E to the x times sine of x, and then subtract the integral of e to the x sine of x. Now, because this is a plus sign here, when I distribute it in a plus sign, it actually doesn't change any of my signs. So you don't need this set of parentheses. If it was a minus sign, then you would want to have that set of parentheses so that you'd remember to distribute in your minus. And this is what I notice. Well, crap. Look at this. I have e to the x sine of x dx there. And I know that if I were to do the integral of this, I'm going to get this because that's what I started with. So if I continue to do integration by parts and I go over and over and over again, this is going to go on forever. But I can do algebra. Look at this. This is exactly the same thing as this. If I have exactly the same thing on both sides of the equation, I can move that thing to one side of the equation because ultimately this is what we want. We just want to get the integral of e to the x sine of x dx alone on the left-hand side of the equation. So let's go ahead and add this over to here. If I add that, I'm going to add the integral of e to the x sine x dx. I'm going to add that to this side. And what I notice is I have two. I have two of them. I have 2 e to the x sine x dx. So 2 times the integral of e to the x sine x dx equals the rest of this. Now, I am searching for the integral of e to the x sine x dx. Is there any way to get that alone? Yeah, I could divide by 2. I could divide by 2. And if I divide by 2, then what I'm left with is the integral of e to the x sine of x dx equals negative e to the x cosine of x plus e to the x sine of x divided by 2. And we solved it because we have e to the x sine of x dx by itself. Now, you're done. But I just want you to know there's a lot of different ways to write that. You could also have written this as 1/2 negative e to the x cosine of x plus e to the x sine of x. You could have also written this as negative 1/2 e to the x cosine of x minus e to the x sine of x. You could have also written this as negative 1/2 e to the x cosine of x minus sine of x. All of those are exactly the same thing. So what I'm going to challenge you to do is I'm going to challenge you to find the integral of e to the x cosine of x dx. That's my challenge for you.